In this lesson, we are going to be looking at binomial expansion, but I want us to start with some special products which you need to know for ACT and also for other standardized tests. And also for whatever we are going to be doing, it's good to know these ones by heart. So see, the first one is the difference of two squares. So we get a squared minus b squared. This one, when we multiply this together, we get a squared plus 2ab plus b squared. So this one here, we get a squared plus minus 2ab plus b squared. The next one here, and remember we can, all these ones we can do them using the method we used in 4.2 part A. This one, when we multiply, we get a cubed plus 3a squared b plus 3ab squared plus b cubed. And then the next one here, we get a cubed minus 3a squared b plus 3ab squared minus b cubed. And as we do this, I want you to pay attention to these coefficients, like here these coefficients right there. See, like this is 1, 3, 3, 1. So those coefficients will be important when we go to okay. So here I also want you to, so whatever we just did, the special product, is good to remember those ones because you just know them by heart, or you can always do them from scratch. So see, this one, if I multiply it, I'll get 1. This one, what would I get? I'll use a special product. This is going to be x squared plus 2x plus 1. See, I'm using the special products from the previous problem. This is just going to be x plus 1, and this is going to be x cubed plus 3x squared plus 3x plus 1. Okay, now let's talk about the coefficients. So here, see, this is just 1. Here, remember, there is 1. Remember, here there is 1. And I want you to see that when x is raised to power 0, what do I get? I get 1. So here, and when I raise it to power 1, what do I get? 1, 1. So this is going to be, I'm going to do, this is the degree, and this is the degree of 0. This is degree of 1, 2, 3, 4, 5, and I can keep going. So what will be the coefficients when the degree is 2? It can be 1, 2, 1. What about when the degree is 3? 1, 3, 3, 1. Now let me see whether I can see a pattern and be able to continue from here. See, this is 1. 1 plus 2 is 3. 2 plus 1 is 3. So 1. So the outside is 1. 1 plus 3 is 4, and this is going to be 6, 4. This is 1, 1 plus 4 is 5, this is 10, this is 10, this is 5, and this is 1. This is 1, 6, 15, 20, 15, 6, 1. And you can keep going. So what we have come up with here is what we call a Pascal triangle. And we use it to expand binomials. It makes our work easy. We just need to know the degree, and those are the coefficients we are going to use. Okay, so now let's do an example. So the degree of 5, this is the degree of 5, and then I'm going to write those coefficients. So here let's do an example of using the binomial expansion. And what I'm going to do here, I'll start by writing the coefficients. And how will I do that? I'll go to my table and find a degree of 5. I'm going to write those coefficients right here. So this is going to be 1, this is going to be 5, the next one is 10, the next one is 10, the next one is 5, and the next one is 1. And you can see they are symmetric. Like as you move from one side, you are approaching the same number in the middle. And then I'm going to start here with x raised to power 5. This is x raised to power 4, x raised to power 3, x squared, x to power 1, and this is x raised to 0. And then the next thing I need to do is to see I have x plus 1, so there is that 1 here, so that's 1 raised to 0, 1 raised to 1, 1 raised to 2, 1 raised to 3, 1 raised to 4, 1 raised to 5. See, when you add those two exponents, you should always get 5. Now I'm just going to simplify what I have. See, this is still 1, this is just x to power 5, and that's just 1. So this is 5, and this is x to power 4, that's 1. This is 10, this is x cubed, and that's 1. 10, x squared, 1, 5, x, 1, and this is 1, 1, and 1. Okay, now I just need to write the final answer. So it's going to be x to power 5 plus 5, x to power 4 plus 10, x to power 3 plus 10, x squared plus 5x plus 1. So that is the answer for the binomial expansion. Okay, let's do another one here. So here we have the degree here. Was the degree here? The degree here is 6, and we get so the degree is 6, and we have 7 coefficients. I just need to write them out. So this is 1, the next one is 6, next one is 15, the next one is 20, the next one is 15. I'm just getting this from the coefficient, from the Pascal triangle. This is 15, And the next one is, okay, so I got 20, 15. Why did I write 15 twice? This is 6 and this is 1. And then all I need to do is to write the x to power 6, x to power 5, x to power 4, x to power 3, x squared, this is x power 1, and x to power 0. And then the next one is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6. And on my next step, I just need to simplify that. See, this is 1, x power 6, and the other one is 1. So this is 6, x power 5, that's 2, that's 15, x power 4, and this is 4, and this is 20, x cubed, and this is 8, this is 15, x squared, 2 to the power 4 is 16, and this is 6x 32, and this is 1, 1, and 64. And now I just need to write my final answer, plus 12x power 5, I'm just multiplying those ones, plus 60x power 4 plus 160 x to power 3 plus 240 x squared plus 192 x plus 64. Okay, so that is the answer there. Okay, so our next example, this is going to be a degree of 4, and we have 5 coefficients. So we start with 1, then n raised to 4, and then negative 2 raised to 0, plus the next one is 4, then n raised to 3, negative 2 raised to 1, plus 6 n raised to 2, negative 2 raised to 2. And then the next one is 4 n raised to 1, and then negative 2 raised to 3, and finally 1 n raised to 0, negative 2 raised to 4. And then let's just simplify. So this is n to power 4, and the next one is, this is going to be actually negative 2 times 4, so minus 8 n cubed. What about the next one? This is negative 2 squared, so that's 4 times 6, 24 n squared, and this is negative 8 times 4, so actually that should be negative 32 n, and then the last one is 16. So that's the answer there. I want you to see that some of them are negative because we had a negative 2. You got to be careful when you're doing the negative to make sure you do it right. That's why I put it in parentheses to make sure I don't make a mistake. So for this example, I need to find the coefficient of a cubed. So I actually don't need to work everything out. I just need to know the coefficients. Like this is that's going to be 1 from the table. This is going to be 5. And this is going to be 10. See, this is a. This is going to be a to power 5 to power 4 to power 3. So this is going to be 2a to power 3. And what else? This is the one I need to work out. And the next one is going to be 3 to what power? This is 0, 1, 2. So that's all I need to do. So this is going to be 10. This is going to be 2 to power 3, a to power 3, and 3 squared. One common mistake is to forget to do 2 raised to whatever power. Like this one is 2 raised to power 3. And students always remember the 8 to power 3, but they forget the 2. So this is the same as 2, 10. This is 8, a cubed, and this is 9. So we multiply all this, we get 7, 20, a cubed. But the question was asking, find the coefficient, so the answer is 720.